don't, because Miss Swisher borrowed mine today. Alright, so we mostly just need it for Desmos. If you want to look on with Jeremy, it'll be fine. If yours is about to die. Okay. Alright, so alright. So I don't know if you guys have ever done this before, but let's just do it right now. My favorite thing to do is just like crafty stuff, like making junk. And whenever I was like a little kid, I can remember doing this. So I'm gonna show you guys what this is talking about. If I can find my scissors that are usually in here, but they're not. I've got some back here, but thank you. All right. Okay. So if I take an 8.5 by 11 sheet of paper, like I've got here, and I'm going to cut squares out of the corners. So I don't want them to be too big. And I also want them to be, let me draw one so that, let me measure one so I'll do it right. Alright. I'm going to take 2-inch square. Okay. Alright, so if you look, I'm going to take this square right here. I'm going to cut it out of the corner. Like that. Right? Then I'm going to cut out the same size square out of all of the corners. Okay, just keep on cutting out my squares. This isn't going to be perfect, but hopefully it'll be close enough for me to fold it up. Okay? Alright. And then I'm going to fold each one of these in. Like this. And if you do that, you will end up with a box. How precious. Okay? And if you think about like actual boxes, they have little flaps to keep them like together. But that's pretty much what happens like if you were at a company that was making packaging for cereal boxes or something. It's pretty much very similar to what you do, right? You'd have a flat piece of cardboard, it would fold up to make something like this, right? So the question is if you use this piece of paper, like I've done here, what is the maximum volume you can have for the box? Okay? That is what we are going to explore here in this case. Now, I want to think about what I just did for my box. The box that I had here, I had a sheet of paper. Well, let me do this up here. I'm going to do this up here because I am recording and I have some that are not here. So I won't do it on the whiteboard. So the box that I just had, the one I just made, this will come up. Gracious, it's slow. Okay. I had a piece of paper. It was 8.5 inches by 11 inches. The squares that I took out of the corner were 2 inches by 2 inches. Alright, so, and I'm going to put like this dotted line, these dotted lines right here. Okay, so if you think about this box, whenever I want to find the volume of this box, this would be like my length, this would be my width, and this right here would be my height, right? So, if I flatten that out, right, this piece right here is my length, this is my width, and the length of that square is my height, right? Because it gets folded up and becomes the height. So, in this picture right here, we could call this section right here my length. We could call this part right here my width. And we could call this right here the height. So, height is definitely 2 inches. Right? What would the length be? It's not 8. That would not be my length. It will be something. That would be my width. Because on this side, the length of this side was 8.5. And then I took out 2 inches right here, and I took out 2 inches right here, so that width would be 4.5, right? So width would be 4.5 inches. What would the length be? All right, I'm hearing Victor say that it would be 7, because this side was 11, and then you took out 2 here, and you took out 2 here, and so that gave you a length of 7 inches. Now, once we've got this, length times width times height is all we've got to do for the volume, right? So for the box that I made right here, you would just do 2 times 4.5 times 7. Okay? 2 times 4.5 times 7. And let's just use the calculator on that real quick. 2 times 4.5 times 7 is going to give us 63 cubic inches. Now, my question is that the most volume we could have? I don't know, right? Like, should I make it, like, more shallow, or should I make it deeper? I don't really know. It's hard to tell, right? So, we could use math to find exactly the best dimensions for this. Because let's say that you are a company and you want to use the least packaging possible, right? So, you want to use the least amount, but you want it to hold the most product. So, if we go back over to our notes now and look at this problem, let's say that we don't know, because we do not know what the length of that square is. All of these are just X. But we do know that the length of this side is 11 inches. And we know the length of this side is 8.5 inches. And much like we did on that other problem, this side right here, this piece right here would be my length, and this piece right here would be my width, and then this piece right here would be my height, where I fold it up, right? So one thing I do already know, that height is just going to be X. I don't know exactly the number, but I know the height would be x. What type of equation could I write for this length right here? I'm starting with 11, right? Because the length of this side right here is 11. What am I taking away? Like over here, I took away 2 inches on this side and 2 inches on this side, right? So it's 4 total. But for this, I don't know how long that piece is. I just know it's x, right? So I'm subtracting x from this side and another x from this side. So could I write it like this? Minus 2x, right? 11 minus 2 times whatever the length of that square is, okay? So if we take that similar, what would I write for my width? 8.5 minus 2x. Okay, I'm going to put some parentheses around this. I'm going to put some parentheses around this. Our volume formula here is length times width times height. Right? So what we're going to do is we're going to do V equals, our length is 11 minus 2x. Our width is 8.5 minus 2x. And our height is just x. Okay? Now, I want to know what the maximum volume would be. This is going to create an equation for me. I'm going to go over to Desmos, and I'm going to type this equation in. I'm not going to use a V. I'm going to call it like f of x or y equals, and then I'm going to type in that equation. So it's going to be 11 minus 2x times 8.5 minus 2x times x. And if I zoom out, it's kind of hard to see. A lot of times what will happen with this is you'll get a lot of answers that are like way outside of what would make sense for this. So like it does like go on up here where like you have like high numbers at 6.73. But can I cut a 6-inch square out of the corner of this paper? No, because I could cut out a 6-inch square, but then I wouldn't be able to cut it out of the other edge, right? So like the highest you could possibly go would be like 4.5, or not 4.5, 4.25, and then you would like have no paper left. So it wouldn't really work for that either. So really, I don't need this stuff over here. I just need this part in the middle. Instead of zooming out, I'm going to go over here and just make my y-axis go up to like, let's see if 50 gives us enough. No, let's go like 100. Okay, that looks good. Okay, so I'm looking for maximum volume. If I click right here, it'll put me a little gray dot right here. Anything past this point, that 4.25, just doesn't make sense for this problem because I couldn't actually do it. And it also doesn't make sense to have negative numbers for this, so I wouldn't want to look below this point. But my maximum is right here. And 1.585 is what you would cut out for your maximum volume, and it would give you 66.148 as your answer. Now let's see what this question asked. Was it asking for the length? It says, what is the maximum volume you can have for the box? So this question is asking for the volume. The volume is your y coordinate here at 66.148. So our answer for this problem would be 66.148 cubic inches. Now we would probably have not been able to guess that, right? We wouldn't have been able to guess that you need 1.585 whatever inches for your box. So mine is pretty close to being maximum volume, but if I wanted it to be maximum volume, I should have made my edges just a little bit smaller there. Okay? So what we're doing here is we're taking like a real life situation and we're turning it into an equation so that we can optimize or find the best possible scenario. This is something that you do a lot if you are in like sort of like a engineering design sort of situation. All right, let's look at this one. Okay? A grocer wants to sell fruit in boxes that are cut from a 36-inch square of cardboard. If he makes a box that has a height of 4 inches, what will the volume of the box be? Okay? So first thing when you see something like this is you've got to decide like what your length, width, and height are going to be. So like the length of the box is this side right here. That is our length of the box. Okay? On this diagram, where is that length? Okay? It's almost where the 30, does it go all the way across? No, it'd be like this piece right here. That would be your length. Okay? So that length is going to be, the length of that side's 36. What would I have to subtract from that 36? 8. Or I'm going to do minus 4, just to make sure you guys realize that's because we're subtracting 4 inches right here and 4 inches right here. And so if we do that, we're going to get that there is a length of 28. So the length is 28 inches right here. Okay? What would our height of this box be? Okay? That is going to be 4 inches because this is the little piece that you're going to fold up, plus it tells you the height is 4 inches. Okay? And then we need to find the width of this box. On this picture right here, that is going to be like this section right here. That is your width. Or we could call it this right here. Alright, who can tell me what that's going to be or how to find it? That one's the hardest one. So, first of all, there's 2 widths along this length right here, along this side, right? So, what if I take this and I like cut the box in half right here? How long is this piece right here? So just from here to here, what's the height of that right there? 18. It'd be 18 because it'd be half of 36, right? What was the length of this little piece right here? That's 4. So if I do 18 minus 4, I will get 14 for my width. Now, all of that is kind of hard to come up with, but once I do that, now I just have a box, right? So my volume would be 28 times 4 times 14. Okay? And if I do that, and somebody do that in the calculator. Where's my, there it is. 28 times 4 times 14. We get 1568. 1568. And that would be cubic inches. Okay, questions? All right, now, if you'll look at the next part, it looks like it's the exact same question, but this time, it doesn't say 4 inches. What does it say? It's got an X inches here. Okay? Do not pack up. We're finishing this problem. All right. So, my length is right here. right? That's this part right here. What is it now? It's not 36 minus 4 minus 4. What is it? 36 minus, this will be an x here, an x here, so it's 36 minus 2x. Okay? What is my height? Right here. It was 4. What is it now? It is x. Okay? Width is definitely the hardest one here. But we're going to think about the same thing. If we cut that in half, right here, this is 18. Okay? And this part right here is x. So my width would be, it's just going to be 18. You're just subtracting 1x right there, because if you cut it in half, there's only like one of those heights that gets cut off. So, I can make my volume equation. It is going to be 36 minus 2x times 18 minus x times x. Okay? Now, it says, if I want to maximize the volume, what should the height be? So I would go over here to my Desmos calculator. I would type in this equation that I've just came up with. I'm going to call f of x equals 36 minus 2x times 18 minus x times x. And when I graph it, I can't even see at all what's going on. I'm going to go over here to the y-axis. Let's make this go up to 500. That's not enough. Let's do 5,000. Well, that'll work. There we go. All right, so I'm looking for maximum volume. So we can see right here, my height of the box should be 6, and the volume is going to be 1,728. Notice that this question over here said, what should the height of the box be? So it's asking for height, so we would say height equals 6 inches. Okay. If it had asked for volume, that's where we'd have the 1748 or whatever it was there, but it asked for height, so this is our answer. Okay. All right. There is no homework tonight, but remember that you have that practice quiz you can do for extra credit. I would highly suggest that you do that. I have tutoring in the morning. You can come in here and work on that practice quiz during that time if you want.
What about the math basic?
What?
Delta math basic?
Yes, I'll do finish the Delta Math Basic. If you didn't get that done, that is homework.